We're taught a planetary model of the atom, particles orbiting a center. To understand the true nature of matter, that model must be shattered. Modern chemistry and physics revealed that the architecture of an atom does not operate on fixed paths or solid boundaries. To build a more accurate model, we start with a specific starting point: the three particles that construct the universe. This table identifies those three subatomic building blocks: protons, neutrons, and electrons. These particles are strictly separated in space. Protons and neutrons reside in the nucleus, while electrons occupy the outer electron cloud. We are going to construct the modern atom from these first principles, defining its core identity and mapping its complex quantum architecture. Knowing these three particles is only the beginning. The physical nature of matter is dictated by spatial geometry and strict quantum rules. Let's start at the center. To grasp the spatial disparity of an atom, consider its total volume. If we shrink that outer boundary inward by a factor of 100,000, we reach a cluster measuring just 10 to the minus 15 meters. All chemical identity is locked inside this small, dense core. The property that defines an element is its atomic number, represented by the letter Z. This is the exact integer count of protons residing in the nucleus. This metric is absolute. Adding or removing a single proton changes the element entirely. The nucleus also contains neutrons. These add mass without altering the electric charge. Notice how the mass counter increases while the atomic number remains locked. The total sum of both protons and neutrons defines the mass number, represented by A. Because neutrons do not affect the atomic number, atoms can have the same Z value but different A values. These are isotopes. Isotopes of the same element have identical chemical behaviors despite their different weights. While the nucleus contains nearly 99.9% of the atom's mass, it occupies practically 0% of its physical volume. This dense nucleus anchors chemical identity, but it does not dictate the atom's physical size or spatial behavior. For that, we move outward. Traveling outward from the dense, heavy core, we leave the nucleus behind and enter the vast, largely empty space of the electron cloud. The 1913 Bohr model depicted electrons moving in fixed concentric circles. Modern observation shows this concept is incorrect. The major shift toward a modern model began with physicist Louis de Broglie. De Broglie's hypothesis states that electrons exhibit both particle-like and wave-like behavior simultaneously. This wave behavior led Werner Heisenberg to prove that tracking an electron's exact path is mathematical.